Assalamualaikum warahmatullahi wabarakatuh. Thank you everyone. Let me introduce myself. My name is Annisa Nilam. I'm going to present our newest article paper title is The Role of Rice Husk in Enhancing the Material Properties of Fly Ash-Based Self-Compacted Geopolymer Concrete. First, concrete was chosen in construction because it is easily formed according to the desired contraction. The current reality there are also obstacles which result in difficulty in compaction, so there is constraint encourage the concept of concrete technology named self-compacting concrete or SCC. But increasing use of concrete also increase the use of cement can have a big negative impact on the environment. Geopolymer concrete is an alternative material to substitute for cement, but due to its viscosity. To solve this problem, self-compacted geopolymer concrete or SCGC has been introduced. SCGC is produced through industrial, using material containing extra alumina and silica can be used. This ingredient can be activated by adding alkaline solution. As an alternative to geopolymer concrete, fly ash can also be used, because the amount required more than 8 million tons fly ash in 2019. Another alternative material for making geopolymer concrete is adding rice husk. In 2014, rice production in Indonesia more 70 million tons of milled dry unhulled rice. The ash content of rice husk itself has quite high silica. Theoretical foundation. Geopolymer concrete is concrete with an innovative binder and replaces the entire Portland cement. SCC is a type of concrete that can be poured and flowed with its own weight. Material concrete maker is aggregate, binder, admixture, and alkali activator. Aggregate can be divided into two, fine aggregate and coarse aggregate. Binder. Fly ash is a product from the rest of coal burning. It can be useful for saving the environment. And the second, rice husk ash are the skin for covering rice. Next, admixture is an additional material in concrete that serves to modify the characteristics of concrete. Alkali activator is an added material that can increase the microbiological breakdown in the pile of organic matter. The alkalis used are natrium hydroxide and natrium silicate. Alkali activator. Natrium dioxide functions as an activator of the alumina and silica elements contained so that it can produce strong polymer bond. Natrium silicate is used in the synthesis process to accelerate the geopolymerization reaction. Mixed design planning method. Self-compacting can be obtained by controlling the binder water factor and superplastizer dosage, and using FNORC 2005. And this is the specification for self-compacting concrete. The tensile strength test serves to evaluate the shear strength resistance of the structural components, and concrete porosity is a level that describes the density of the mixture. This is formula for tensile strength and the right side is porosity. Research methodology. This is amount of material, manufacturing of sample, manufacture of cylindrical tensile strength specimen, and for cylindrical porosity. Variation in the proportion of rice husk used 0%, 5%, 10%, and 50%. Testing at the age of 28 days. For standard, the split tensile strength test uses the Indonesian National Standard 2002. The porosity test uses the ASTM standard. Result and discussion. This is the result of aggregate test. And this is the result specific gravity of rice husk. Result tensile strength. To find out whether the variation is significant or not, it can be done by using the F-test. The result is not significant, can be seen in the following table. The addition more than 0% rice husk S increase from geopolymer concrete. This is due to the content of silica and alumina in rice husk S. This polymer bond will be stronger. The high silica content will reduce calcium hydroxide and produce calcium hydrate as an adhesive. Look at the reaction. The addition of rice husk S substitution of more than 10% will reduce the split tensile strength value in the concrete, which should have the silicon dioxide reacting with calcium hydroxide. The amount of calcium hydroxide from the hydration reaction is less, so a lot of silica is deposited and calcium dioxide content in rice husk and fly ash lower than cement. The use of natrium silicate and natrium hydroxide and curing at room temperature also raises a pure wet flakes on the surface. This is because the less silica and aluminate content. Natrium hydroxide is what reacts again with air to form sodium carbonate and calcium carbonate in the form of white precipitate. This is result percentage of porosity. To find out whether the variation is significant or not, it can be done by using the F-test. The result is not significant can be seen in the following table. The addition of 5% till 15% rice husk S decreased the porosity can be seen in the following graphic. The use of fly ash and rice husk S in the study has increased. This occurs because the lack of burning in the concrete with an activator is not the same as that of cement with water. The iron content of fly ash is higher than the iron content in cement. The presence of iron oxide reaction to air from iron hydroxide, which produce air bubbles during the stirring time, which causes trapping of air in the concrete so that the concrete tends to be hollow. From the porosity test result, it can be seen that the more the rice has S content, causing the porosity value to also decrease. The addition of rice has S of more than 10% caused the percentage of porosity to increase. This is because the silica content is too high, which causes silica to not react and reduce to bond. Conclusion: first, variation of rhesus S substitute did not have a significant effect, and the second, the optimum variation of rhesus S was 10% for the split tensile strength and porosity of the geopolymer concrete. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.